Okay, this is how to derive an exponential equation. Method 1, I'm showing 3 methods. This is the first and the easiest. They're all easy though as soon as you know how. I have a separate video that shows how to do the tests to see if this is a linear, a quadratic, or an exponential relationship. So I'm not doing all of that in this video. Instead, I'm just going to do the last step, which is the exponential. So the test for exponential is constant ratio or constant quotient. We divide. We divide the second y by the first y, which in this case means 8 divided by 2. I show that here. And then we do the third divided by the second, the fourth divided by the third. You do that with as many points as you have in the table. And 8 divided by 2, of course, is equal to 4. I don't need a calculator for this one. 32 divided by 8 is equal to 4. We started to see this must be exponential because it's giving us a constant ratio. 128 divided by 32, of course, is also equal to 4. It's exponential. Now, this is how clean and nice it looks when the values are very clean and nice, but very frequently with exponential equations, you're going to have values with a lot of decimals. And if you have that, there is a likelihood that those decimals were rounded. So the answers you get to the constant ratio, constant quotient may not be perfectly the same every time, but if they're really, really close, it still means that it is exponential. Let's do this. I am going to use the calculator this time. Brush off the chalk dust first. Okay, so second y 2.24 divided by first y 1.4, 2.24 divided by 1.4 equals 1.6. Third y divided by second y, 3.584 divided by 2.24, 3.584 divided by 2.24 equals 1.6. Third one, 5.734 divided by 3.584 equals 1.59988. We get a value that rounds to 1.6. Okay, this happened because the person who created the table of values, which was me, had to do rounding in order to be able to fit the answers, to fit the y values into the table, because you end up with exponential equations with these decimals that go on and on forever. So if it's really, really close to 1.6, it's 1.6. We have a constant ratio, therefore we know that this is exponential. Okay, enough about doing that test. Now that we know they're exponential, we want to find the equation. Well, when they give you the point where x is equal to 0, it's a really, really quick process. It's nice and easy. So what we are doing is we are writing the form for an exponential equation, which is y equals a times b to the x. And then we are plugging in the point 0, 2 into the xy positions. So 2 equals a times b to the 0. But of course, if you know your laws of exponents, b to the 0 is equal to 1. Anything to the 0 is equal to 1. So that cancels. Basically, we have 2 equals 1a or 2 equals a. We can just write 2 equals a or a equals 2. That means we know that a is 2. We can write our form again, but we are putting a 2 instead of the a this time. Now we have to figure out what the b is, and then we will have our exponential equation. So to figure out what the b is, I'm going to plug any other point from the table of values into this form. I'm not going to use the 0, 2 point again. It won't work. But I can make it as easy as I want for myself by using the simplest looking point like 1, 8. Instead, I'm going to use 3, 128 because I'm up for a challenge. So the 128 is a y, and the 3 is an x, so I have 128 is equal to 2b cubed. Well, what we need to do now is simplify with algebra. So we're dividing both sides by 2. These cancel. We have b cubed, it's hard for me to write on this side of the chalkboard, is equal to 64. And then you might know the cube root of 64 by heart, like a math teacher, but you also want to be able to use the y to the x key and the xth root of y key in your calculator. This is necessary when you're doing this type of math. So whichever method you use, when we find the cube root of 64, we see that b is equal to 4. Because of course 4 times 4 times 4 is equal to 64. Therefore, I have my equation. I ran out of room to write it, so I'll write it here. Y equals 2 times 4 to the x is the equation that was used to create this table of values. And then, of course, if you're in the middle of a word problem, you will probably have to plug values into that equation in order to answer the final question. So, exponential situation. We prove it's exponential first by checking for the constant ratio. Once we know that, we do this two-step process using the form for an exponential equation, and we're able to figure out the a and the b, and then we're ready to go and do whatever it is that we need to do with it. We're going to do this one more example. So I'm doing the exact same process. The form is y equals a times b to the x. I'm going to plug in the point where x is equal to 0, and when I do that, 1.4 is equal to a times b to the 0, but of course b to the 0 is equal to 1, so this means 1.4 equals 1a, or 1.4 is equal to a. I know that a is therefore 1.4. I rewrite my form, y is equal to 1.4 times b to the x, and then I plug in any other point I want. I can be a show-off and pick the point with the biggest numbers, but this time I'm going to not be a show-off and I'm going to pick this point where x equals 1, so I have 2.24 equals 1.4 b to the 1. But of course b to the 1 is b. I don't have to write that exponent. When the exponent is 1, you don't have to write it. So 2.24 is equal to 1.4b. I can simplify, I can isolate my b by dividing both sides by 1.4. I'm not going to be super surprised when I do that if the answer is that b is equal to 1.6. It's not really that big a surprise. It wasn't that big a surprise that b is equal to 4 with this one either, was it? So we can see that this actually becomes very easy if you practice it enough. So get enough practice so that you don't forget when you're sitting in an exam how to do this very simple two-step process. So therefore our equation is y equals 1.4 times 1.6 to the x. And then I can plug values into that equation in order to answer my question. That's it for method 1. Stay tuned or check for my other video that's about method 2 and a third video about method 3. If you can do all 3 methods, you can do anything that the course I'm preparing students for asks them to do with exponential. And of course, don't forget to give this video a great big thumbs up and share it with everyone you've ever heard of on Facebook, or do whatever else it takes for you to make me famous and rich.